This lesson is over how to properly write a multimole ratio. Now, before you write a multimole ratio, it is so important that you start off with a balanced chemical equation. So if you still don't know how to balance chemical equations, you might want to watch one of my other videos on how to do so. When we balance equations, we're going to be using those coefficients in order to write multimole ratios. But before we get to a chemistry example, let's try to understand multimole ratios through a food example. Here are some ingredients that you would need for a simple cheeseburger. You would need 2 buns, 1 patty, 1 piece of cheese for a cheeseburger. Now I can take any 2 pieces of these ingredients and I can write a ratio between any 2 ingredients. So here's a ratio between buns to cheeseburgers. I need 2 buns for every 1 cheeseburger, and this is a symbol, pretty common symbol for ratios. I can write a ratio between patties and cheeseburgers by saying I need 1 patty for every 1 cheeseburger. I can also write this ratio between cheese and cheeseburgers, and not only can I write a ratio between something on the left side of the equation versus something on the right side of the equation, but I can write a ratio between any 2 ingredients on the left side of the equation only, like so, 2 buns for every 1 patty. I can also write that there are 2 buns for every 1 piece of cheese. That's another ratio I can write. I can also say that for every 1 patty in a cheeseburger, I would have 1 piece of cheese. So these are actually all of the ratios you could possibly write for this equation, but we're really going to be focusing in on one, and I'll show you how to do that in another video. For this chemical equation, I have sulfuric acid plus 2 moles of sodium bicarbonate, also known as sodium hydrogen carbonate, to form 1 mole of sodium sulfate plus 2 moles of water plus 2 moles of carbon dioxide. Now, just by looking at this equation, I can tell right off the bat that it's balanced because I do see coefficients, several 2's, throughout the equation, so I can almost assume that it's balanced and I don't have to put in that extra work to balance it out. So I want to show you how I can specifically write multimole ratios between any 2 pieces of this equation. If I asked you the following question, what's the relationship between sodium hydrogen carbonate and sodium sulfate, what you would do is you would focus in on those 2 pieces of the balanced equation. Here's sodium hydrogen carbonate, here's sodium sulfate, and I would use those coefficients of 2 and 1 to say for every 2 moles of sodium bicarbonate, same thing as sodium hydrogen carbonate, I have 1 mole of sodium sulfate. So we're just using the coefficients. If I asked you the next question, what's the relationship, same thing as a ratio, between sulfuric acid and carbon dioxide, I now focus in on those 2 pieces of the balanced equation. Remember, it has to be balanced. And I would end up with 1 mole of sulfuric acid. For every 1 mole of sulfuric acid, there are 2 moles of carbon dioxide. Just for a little more emphasis, here are some arrows to point out exactly where these coefficients are coming from.